Data protection and privacy teams are under more pressure than ever with new laws, AI oversight, data breaches, and the constant expectation to do more with fewer resources.
That's why TrustArc built a modern privacy and data protection management platform powered by Arc Intelligence. It unifies your tools, automates the work that slows you down, and surfaces what matters most right when you need it.
From guided quick actions to our intelligent assistant, Ask Arc, you get credible, contextual answers backed by expert research, not generic AI guesses.
Finally, privacy that works the way privacy pros work.
Learn how TrustArc helps teams move faster with confidence at trustarc.com/serious-privacy. That's trustarc.com/serious-privacy.
You're listening to Serious Privacy by TrustArc. Please welcome our hosts, Paul Breitbarth and Kay Royal.
As you will know by now, Kay and I are both lawyers. Sorry, we can't help it either. But privacy and data protection are not just a job for lawyers, not anymore. Technology plays an important role in ensuring personal data can remain private, and I'm not just talking about compliance software. Ensuring the data is actually secure, that it is encrypted to decent standards but still remains useful, is a whole different ballgame, often put in the hands of data scientists. Our guest today is such a data scientist. Katharine Jarmul is the head of product at Cape Privacy, a New York-based company assisting others with machine learning, data security, and adding value to your data. With Katharine, we will speak about what data science actually is, how to keep data private, useful, and valuable at the same time, and much more. My name is Paul Breitbarth.
And I'm Kay Royal, and welcome to Serious Privacy. So today is going to be a lot of fun because we know that data science has come up a lot in our podcast, different aspects of it. So our unexpected question of the day is bad news. I don't know if this must be on my mind in America right now, but bad news, sugar-coated or straight up?
I feel like, I'm a Californian originally, so I was very much a sugar-coated person, but living in Germany for the past 7 years has made me very straight up. So I feel like I made that migration. How about y'all?
Paul? I love the y'all.
Oh, I would say straight up. I'm Dutch, so we're used to being blunt.
And I would have to say, for me, it's the same thing. It's straight up. I have been accused by Europeans of being the most blunt person they've ever met. and they do say, however, I am the most polite blunt person, but the most blunt person they've ever met. So
why would you sugarcoat anything? What is the added value of sugarcoating bad news? I mean, the news is not better.
Well, and I have to say, years ago, my daughter was 11 when the doctor had to give her some bad news, and she was sugarcoating it. And my daughter finally just turns around and looks at me and says, Mama, what is she trying to say? I said, she's trying to say you got lupus, kid. And my daughter's like, oh, that's what I thought she was trying to say. Why didn't you just say it? 11 years old.
The apple doesn't fall far from the tree, right?
No, they really don't. Okay, we actually have some stuff to talk about today, Paul.
Absolutely. And let's start with the most straightforward question we can start with. Katharine.
No sugarcoating.
No sugarcoating at all. What is data science? Tell us, explain us.
Yeah, that's a great question. I think it's still something that's up for debate within the data science community itself. So it sometimes depends on who you ask. What I would say, and I think the more generally acceptable definition is data science is a little bit of the study of data itself and the data related fields that we can apply to it to gain insights or predictions or other types of value that we can get from the data. So I would define it broadly enough to include things like data analytics and business intelligence, as well as like what we think of kind of today as more traditional data science, which has a little bit of coding and maybe a little bit of understanding or exploring the data and providing some insights from the data based off of those, and then all the way to more advanced where we can talk about simple machine learning, statistical modeling, and then advanced machine learning, something like deep learning or something like this.
So how did you get into data science? How does one choose to become a data scientist? It's probably by chance like privacy lawyers that exist today, but tell us more.
It's true. I mean, so now the really great thing about data science is you can get a degree in it. But when I was going to school, you couldn't yet.
Mm-hmm.
So I studied computer science originally. And when I got to university, I had the unfortunate experience of being one of the very, very few women in my field. It was not exactly super friendly or exciting. So I actually moved over to political science and economics, where I ended up studying quite a lot of statistics, right? So like if you do social science, you study a lot of statistics. I was always really good at math. So that made me happy. I went through a weird route and I eventually ended up in data science by way of data journalism. So I was a journalist at the Washington Post and I was helping them build applications to answer questions around data. And that's when I really got back into coding and computers. And that was in 0708, which was a really exciting time to be working at the Post, obviously.
Oh, yeah. Oh, yeah. That's really fascinating. And I don't say that just because it is, because math has always fascinated me. But making a career around it is probably not a direction I would go.
I never got math. It's no. Give me text, I'm fine. Give me numbers, I go crazy.
Well, I'm good with them all except for the taxes, but the IRS isn't listening, so we're good. Yeah, so it really is. And I mean, to the point that when I was looking at getting a PhD, funny enough, I was looking at a PhD in math. Apparently, that's a little hard to do unless you've got an undergrad or a master's degree in math to support the upper level. So I wound up seeking my PhD in public affairs. So kind of the same thing, went from the science to the touchy-feely stuff. But I still find math fascinating. And as we discussed earlier, it comes up a lot on our podcast when we talk about machine learning, artificial intelligence, what you want to do, as well as social justice with bias issues. So Paul and I have all of these questions going around in our head that we want to ask you. So with those kind of topics on the table, which one would you start with?
We can start with maybe a little bit about machine learning. It might then help to build a common syntax or words that we can use to discuss the problems.
Yeah, that would be helpful for me.
That actually sounds useful.
And I'm sure there are more listeners like me.
I think you've been in this position before, Katharine, going, let's set a baseline here.
Yeah. Should I describe a little bit about machine learning or? Okay, cool. So in machine learning, we use the word learning, but it's debatable especially from, I guess I would consider like a philosophical or a legal perspective of if this is what we're doing learning. What I think is a better way to describe it is that we're trying to model something about the world. And then we want that model to be able to do what we call as generalization. So we want to give it a few examples, and then we would like it to be able to look at new things that it hasn't seen and to be able to answer something about them. And so it depends on what type of model and depends on what type of machine learning. So all of these are kind of details. But from like a more general or philosophical point of view, it's like, we're going to show you a few things about the world, and then we want you to try to keep doing that, right? So there's a lot of different ways to go.
You're making me wonder because you hear a lot about AI. So is it I don't even know how to put this, but you might understand what I'm asking. Is all machine learning the same? Is it all running on the same software programming? Is there like a basic thing you do and then it does its magic in the black box? Or are there so many different ways of approaching it that it's just so vastly different?
So I would say that we could talk about like a very simple machine learning problem. We could break it down to steps. But that would only describe maybe like 30 or 40% of machine learning today.
Okay.
But it's become much more exploratory from a research side. So there's now different ways that we might even set up the entire process. And there's different types of computers that we might run it on. One of the things that we're actually working on in my work is how can we work on it with other people? So how can I work on a machine learning model with you, which is a very different type of problem than me just working alone. So it's kind of broadened, but we can kind of break it down to, we define a problem or a question we want to ask. Then we have to find some data. We may have to transform that data or regularize it or make sure that it's the right formats and so on. And then we define an algorithm We show that algorithm this training data. So you might hear about training steps. This is when we're showing it the data and we're asking it to essentially get a better and better answer every time. And then when we think it's ready, we test it with a different data set. And then we might go through some extra steps basically to fine tune it near the end. And then we say, maybe it's ready. And maybe it is and maybe it's not. But that's like, if I were to try to generalize the process, that's how it works for a particular type of machine learning that's quite popular, called supervised learning, if you've heard it. So
supervised learning. Yeah, it makes a little sense. I was listening to people on a panel a few years ago at a tech conference talking about contract management machine learning. And the debate came down to the fact that if you're using your engagement with a client and their contracts to train, which apparently is always an ongoing process. It's not just you learn it up to a certain point and then you go. Who owns that training? That client is contributing to the sophistication of the product. So then the next client benefits from what the machine has learned from the prior client, which really seems to make all the rights muckety mucked up in there, if that's a term of art.
Yeah. I mean, I don't know how many folks have seen the "this person does not exist" website.
Yes.
But this is, trained on many, many faces, and then you generate the faces. But it's like, what are the legal rights of those people to their images? I mean, they were mainly collected from Creative Commons licensing and so on, right? But it's like, if there's a person there that looks like me, does it mean that it's based off of me? And some of these questions we can answer via the model itself, but sometimes we can't answer it even via the model itself. And so, then we get into real big questions, right?
Is it possible to always keep control over an algorithm, or could it go just out of hand and do, well, whatever it wants between parentheses, or whatever it wants, to the extent that it was told to do things?
I mean, so normally we would train to solve a specific task. So I might train image recognition model to tell me whether there's a cat in the photo or not, right? Everybody likes photos of cats. Who doesn't like photos of cats? And so I might say, okay, tell me, is there a cat? Yes or no? What's the probability of there being a cat there? And it would give me a numeric answer, right? Then I couldn't take that model and just say, okay, now tell me if there's a dog, right? So by default, when I train it, I set a certain amount of constraints around the problem that it can solve. So I still think we're a long ways. I would not agree with kind of the Elon Musk ethos of the world that like AI is about to go Terminator on us. I don't really think we're there yet. I mean, we still have problems even with cats, So
if the cats haven't taken over the world yet.
But the very real problem that you referred to earlier, Kay, is that sometimes when we're asking that question, we're not thinking about the implications of the answer to that question. So if instead of asking, is there a cat in the photo? If I were to ask, is there a terrorist in the photo? Or is this person worthy of a loan or not? Then we can start to infer that might have some biases from, what we showed it when we were trying to train it, or even how we framed that question in and of itself. So how I posed the question to it might also have problems.
So going back to the cat, if you were to train the algorithm only with pictures of black and white cats, would it be still able to recognize a red cat?
Depends on the type of model. In a lot of cases, no. But there are some special models now where they're trying to essentially do some tricky ways of being able to kind of generalize more quickly. And this is happening a lot in the language space. So we see this. I don't know if either of you have heard about GPT-3 or heard about it in the headlines. So there's some, I guess you could call them tricks, I guess, that people are developing where you can more quickly learn about the world and then hopefully better generalize. But as it's all still research right now. So I would say generally the answer to that would be no.
On GPT-3, I actually just heard about it in another podcast in Dutch, unfortunately, so it wouldn't make a lot of sense to share the link in our description. But what they did, they fed the algorithms of earlier podcasts from the show, and the algorithm wrote a new podcast episode, which was very strange, but also strangely accurate. There were some really strange sentences. One of the guys telling that his great-grandfather had been an astronaut, that of course is impossible if you look at scientific history. But just the way they spoke about things was so much like they would usually, and it was very well done. And when listening to it, am I going crazy? What is strange episode is this? And then only after...
Are you saying, Paul, that I'm useless?
No, not yet. We are not useless yet. That's exactly what I'm saying. We still have to do this because the machines cannot completely take over podcasting yet.
Yeah, I mean, that's like a really great example of all of the podcasts that you all have put together and recorded. That could be the training data, right? But one big question that folks have in the research space about how some of these, especially some of these really large models work, is like how much of that information is essentially memorized and stored in the model itself. And if I'm memorizing and storing your data in a model, is that the same, from a privacy perspective, let's say, is that the same thing as me just taking your data and storing it somewhere? I mean, I think that's still very fuzzy.
Wow. I'm sorry. Everybody listening probably doesn't know that all of us were just like, yeah. I'm sorry. They can hear our expressions and our voices, and you can tell that privacy apparently is a lot of fun because we enjoy talking about these things. So let's move over to another one then. What about anonymization? Can we get to true anonymization, knowing that some of the standards are based on something is pseudonymized? And if you don't know what pseudonymized is, it's pseudo-anonymized. So things can be pseudonymized in a company if that company cannot re-identify it with information available to it. Now, I interpret available to it mean you can go get it from somewhere as well. It's available. It doesn't have to be already in-house. But in this world, can we get to truly anonymous data that still has meaning? I know the first part is different, but if it still has meaning and it's usable, is that possible?
I mean, I think that depends on who you're asked to define the word anonymization.
Europe versus the US, right?
Yeah, or, some quantitative privacy folks versus maybe like more applied privacy. So, I mean, I would go back to Cynthia Dwork, and I don't know if you all have referenced her on the podcast, but I'll just give a brief introduction to folks. So Cynthia Dwork is a computer scientist and a mathematician, and she was able to prove, I think it was nearly 20 years ago now, that there's no such thing as anonymization from like a mathematician, like almost like a logical, philosophical proof is what she outlaid. And what she said is that no matter what data you release, you don't know what data other people might have about that person. So if I were to release, I'm going to get the exact example wrong, but it was like the average height of a Lithuanian woman is like, oh, now I'm really going to mess it up because I'm going to say it in feet and inches. So sorry, everyone, is, 5'4" or something like this. Right. And then, but I know that my Lithuanian friend Paula, 2 inches higher than the average. Right. So because I have that extra information, I can automatically tell you something about this other person. And so that's basically the way that she defined theoretically that no data was ever safe to release, quote unquote, anonymized, because you didn't know how it might be connected to other data that people could use to make to get some more private information about someone. And I think that
sounds really.
And so what she and several other folks went on to develop is the theory that rests behind the idea of differential privacy, which is, of course, not actually an anonymization technique, but instead something that allows us to try to measure how much privacy leakage or loss you have given what I'm doing with the data. And so within the machine learning context, and then also some of, what I know here in Europe, at least, is being discussed under GDPR, it's like, can we use something like differential privacy, which can tell us maybe like how much I might have leaked about you? Can we use that to try to say that it's anonymized enough from a legal perspective? Because I would say that probably from a legal perspective, we would say saying the average height of all Lithuanian women is fine to release, right? So that's, I think, the math behind it versus like the reality we live in is like we need to release data and do things with data. So how can we do this responsibly?
So one of our earlier guests in the podcast, Alexander Hanf, is now also working on synthetic data. How would that relate to all of this? I'm still getting to grips with what it actually is that he is doing. But again, I'm just a lawyer.
Yeah, no, I believe I'm familiar with some of his work. Yeah, so synthetic data is the concept. It's kind of similar to what I was talking about, is this person does not exist, is based off of a similar concept. And so it's the idea that I'm going to show what are called generative models. Sorry, I'm giving you a bunch of words now. So I'm
that's okay. I'm jotting them.
I'm going to show you a generative model, and I'm just going to show it a bunch of data. And then I'm going to actually, GPT is also like this. Anyways, and then I'm going to ask it to generate something like what it saw. And that's synthetic data. And so it can be used in a lot of creative ways too. So it's like, I don't know if you saw any of the style transfer where it's like upload your photo and we'll make it into like Mona Lisa style, or we'll make it into that. That's kind of playing with this same concept. It's a particular type of machine learning model that can generate something. You give it a little bit of something and it generates something new. And that's where most synthetic data comes from. Now, the question becomes, how do you protect the data that you're showing it? Because if you only show it Mozart, are you then infringing on Mozart's privacy later? I mean, not really, right? But Mozart's even creative ability later when you ask it to generate. And so that's a problem that you start to run into with synthetic data, is if you have an overrepresentation of a particular individual or a particular set of individuals, you might actually expose their privacy later on. And so it's just, you have to really define what you mean there. And there's ways to combine differential privacy, as I mentioned before, with synthetic data to try to help this problem.
So that could actually be a solution in the longer run, also to ensure that algorithms get trained, because one of the things I keep hearing at privacy conferences is that there is insufficient training data for algorithms for them to properly work and also to take out any biases that may exist. And this could be part of a solution, ?
Technically, yeah, that is like potentially one way to solve it. Yeah. I mean, there's probably numerous ways. We're working on one way as well that's more of what I could say is a collaborative data approach. And so it's more like the idea that you would both bring your data, I'm going to bring my data, we're going to train together, but none of the data has to necessarily leave any of our computers. So we can train together in a way that uses encryption and some concepts of collaborative learning, like federated learning or distributed learning. And we can work together and get one of these models at the end, but it doesn't mean that we have to store all our data collectively. It doesn't mean that we have to try to generate a bunch of new data. It just means we can use the data we have in a more secure and privacy-aware way, and we can know who we're using it with and for what.
The purpose is the same, then we can all bring our data sets, use them for the training.
Yeah. And if, say, Paul, you wanted to contribute your data, but you didn't want to really be a part of the model that comes out, you could join in and Kay and I could build the model together using all of our data, using some encryption techniques. And so at any point in time, if you said, I don't want you to use my data anymore, you could remove your encryption key. Basically, we couldn't use your data anymore. So there's many different kind of technical ways to solve this problem. But I think really where it becomes interesting is like, what is the outcome for the folks involved? And I think from both of your perspectives, like, what is the legal risk or like the security risk of these different ways? And how can we find like the best match for the type of problems that we have, right?
Fascinating.
It really is. And I'm going to ask you, Katharine, because I've been looking up all of these terms you're throwing out so I can provide resources to our listeners. I'm going to ask you to send me a resource that you recommend that would be good for the average privacy or not so privacy person to understand the context of where this is. There's a lot of information out there.
Yeah, and it's really, I mean, that's a really big problem, I think, that I definitely see as a huge blocker to some of this advanced technology is that often it's written only with the idea of other technologists in mind.
And if you want someone like me to adopt it, it needs to be more on a practical basis, which people like me want to adopt these things, but we go out and look and we're like, how do you evaluate something you have no real understanding of what it is and even what the differences are? So it's utterly fascinating for someone in a privacy field working with data to be able to understand the differences between what you're saying without having to go and find an expert and not knowing whether or not that expert is actually good or not because you have no way of understanding what they're doing.
Yeah. And I think, unfortunately, too, some of this advanced technology sometimes is being built themselves in silos. And so one of the big critiques I have of privacy technology, the advanced privacy technology today, is that usually the problem is best solved by some combination of techniques. And yet most vendors, let's say, are providing like one or two. Mm-hmm. Or even if they're providing 4 or 5, they're like, here they all are, you figure it out. And it's like, well, who's supposed to be using this? Like, do I have to be an expert to use this? Like, that makes zero sense, right?
Right.
So,
and how common are experts in your field?
I think, unfortunately, more rare. You feel like you're in a big group, and you zoom out a little, and you're like, oh, okay. So, yeah, I think especially when you think of something like privacy in machine learning or privacy in data science, it starts to get like very zeroed in. And that's why I believe I know personally who you were referring to. It's like eventually you kind of are all like, oh, we're the privacy of machine learning or privacy in data for machine learning folks. And that's really, that's cool, right? To have a group. But it doesn't help a lot if a lot of our conversations are these like internal conversations. I'm sure I've listened to some of your podcasts. You know this also just from a legal context. It doesn't help if only lawyers are talking with other lawyers. Right. Like we have to expand the bubble. So
well, it's one of the reasons why we started the podcast.
Exactly.
To make information more accessible and get others to understand what privacy and data protection is all about. I mean,
right.
We both like to teach, as you probably have heard. So we want to spread the message.
Yes, we're evangelicists. But
a good word.
Right. I was talking to one of my absolute favorite law students. He's 3L at my alma mater, Arizona State University here. He's already got 2 or 3 papers being published. He's already done a TED Talk on privacy. This guy is going far in privacy. There is absolutely no doubt about it. But it's funny enough that he was talking about essentially the same thing, is that you have this difference between academics who talk about privacy and practitioners who are putting it in place. And there's a wide divide between them. And why can't you bring them together? And it's the same thing here. You have these 2 fields that are looking at the same thing, but yet they're almost speaking different languages. And so how do you bring them together so you can leverage one to help the other, regardless of whichever direction it is? How can data scientists leverage the privacy knowledge that privacy professionals would bring about the problems they're facing in order to build solutions or to address their problems? Or are they are they identifying the problems they think should be addressed, and yet we're not seeing it in practice out in the world? So that makes it really an interesting problem, because that brings me to the company you're working for now. And so how is the data scientist play out there? What problem are you addressing?
Yeah, I mean, I think it's a great, point to just double click on a double check there is that, what we've seen in working with a lot of the customers we're dealing with, and what I've seen just being a data scientist in the field is, you have this data scientist perspective that's just like, okay, I just want to do my part of the job, right? Which is usually not related to privacy at all. And usually I'm not incentivized to care about privacy, right? It's not really a part
It's not what you went into.
Yeah. And it's also not even, I'm not rewarded for it. So if I do it just because I think it's the right thing to do, sometimes I'm not even recognized for it, right? So I'm adding a bunch of work to myself and trying to learn a bunch of stuff that I don't know about. And then I'm not even recognized for that, right? So that's one part of the problem.
It really is. And that's more than just data scientists. There's a lot of fields out there working for companies that aren't even privacy companies, just your average company that has a privacy element because, hello, they have employees or whatever customers they're working with. And so they have privacy considerations, but there's no one in the company invested in actually building privacy into what their everyday job is because that's not their job and they're not incentivized for it. But which of us never touch personal data in our work?
Exactly. Yeah. And then as you point out, you might have legal or compliance, depending on the size of your company. You might have a DPO. You might even have an external DPO, right? And that person or people are trying to basically make sure that there's some basic standards across the organization that people know what to do, but may or may not be really a computing and probably not a data science or machine learning person. Right. And so it's how do you translate that standard language or policy language to something that a data scientist can actually operate on and incorporate in a reasonable way. And that's, I think a huge issue. So definitely something we're trying to address. I think there's many people trying to address it as well. But it's kind of that same thing that you were saying is if you have this super advanced technology, number one, how likely is it that the data scientist knows how to use that off the gate? Probably not, right? So they haven't studied privacy. They know machine learning, but they haven't studied privacy.
And the privacy is the context they need to put it into.
Exactly. Okay. And then number two, you have, more legal or privacy aware folks that have actually a lot of understanding of the context and what we should care about and what we should not care about, but they don't necessarily always know how to translate that into the specific use case that we're thinking of, right? So for building a credit card fraud model, what data can I use? What data can I not use? And in a lot of machine learning, we can actually infer quite a lot of private things about an individual by seeing other things about them in the data, right? And so we see this great example of this, maybe a little bit too recent, but is the Cambridge Analytica idea, which is based off of your Facebook likes. I can infer your gender. I can infer your sexual orientation. I can infer quite a lot of things about you just based off of a few things that you liked. And so there we start blurring both the privacy and I think the ethical lines. And if you have a really good DPO or really good folks, they might be thinking at that level and be communicating that. But I think overall, there has to be education on both sides to really figure out what standards fit kind of this new way of working with data.
And I was going to ask what DPO would actually understand the context that you need to put it in to understand what there needs to be. That you're right. Education would have to definitely go both ways, probably more in one way than the other. But
So are you working at Cape Privacy with some kind of ethics review board or an ethics committee that supports you in the work that you do with customers?
Currently, I think we're a little bit too small for an ethics committee right now. Thankfully, I've cut my teeth in a lot of ethical machine learning. So I've actually been a part of kind of some of the fairness, accountability, and transparency in machine learning types of movements and have been a very large fan and follower of a lot of the academic work around fairness in machine learning. What I would say, though, is that what I imagine eventually machine learning looking like in the future, right? If we're headed in the right direction, I would imagine that at any company that's doing machine learning at scale, they would have a process where they could ask a kind of multidisciplinary team about some of the outcomes around that machine learning. And some of those would definitely be privacy related, obviously. And then some of those might be more around transparency.
Can you be transparent?
Depends. Yes.
I love that answer. Paul and I can resonate with that answer. It depends.
It depends. Yeah, it's my favorite answer in privacy.
Sorry.
Oh, no, we get it. We get it. But yeah, I get it. Transparency is one of the things to consider, but how transparent can you be?
Yeah, I mean, that's a really good question. So one thing I would say is that the European Commission around trustworthy AI and responsible AI has been doing some really interesting kind of assessments and recommendations around some of these things. So, I mean, I feel like that's kind of some of the best thought out things, and I'm happy to link. They have some like self-assessment guidelines for trustworthy AI, and I believe there will eventually be some regulation here in Europe around what we define as trustworthy AI and so on. I had the benefit of talking with some of the folks that worked on the German Datenethikkommission. And so this is the Data Ethics Commission around trustworthy AI. They released their report last year. It's quite good. Anyways, it's also in English available somewhere. but eventually I could see that there is a little bit more process around some of that. And there are some ways for us to, especially if you ask me, why did it make this one exact decision? There's some ways for me to answer that question. Okay. Now, the question is that if you change one thing, would it be different? This becomes quite hard to answer in a holistic way. And so when we think of things like overall bias against a particular group of people, this becomes harder to extract out of the model, so to speak, depending on how the model is built. So,
can you retrain the model? So we've touched on in various ways through our conversation on the social justice issue of bias in AI and machine learning. Can you retrain the model? If you identify that there is bias, can you retrain?
Yes. So you can always,
I guess, not retrain, additionally train.
I mean, so it depends on if you think, so it's kind of like this. It's like you have a canvas and you've painted on it. And it's like, do you just really need to add a different color on top, or do you need to start from the very beginning, like from the base? And so we have different ways that we can influence that. So we could just add another little layer and say, okay, now we think it's okay. We could test for that, right? For example. But if you say, okay, really this to the core has some problems, then we would almost want to restart from the beginning. And some of that starts from like understanding our data, right? It's that simple of like, oh, I looked at my data and I realized like I only have people with one skin color, or I only have English language, or I only have this or that. And when you start out with those population biases, then it's very hard to counteract that without getting another different set of data.
And probably it's also hard to admit that, for people to, first of all, recognize that is the case. But once you start looking, you might discover that. But then also admit to yourself and to your peers that you've actually been working with biased data. I think that is also a big challenge for people to overcome from a personal perspective, because I don't think that anybody wants to be biased.
I think, you have, again, the competing demands. It's like, give me something that I need to solve this problem. And, we don't have data that can do that without being unfair. And this is where I really think in the end, or in a future, we need to have collaborative machine learning, because if I'm not training with somebody that has data different than mine, then I very quickly run the risk of coming out with something biased. And this is why I truly believe in more distributed machine learning, because then we could even learn across continents together and try to solve bigger problems than what we're solving right now.
Is this something that the average data scientist thinks about? I mean, I know we do if you specifically pose the ethics question, but when you're working on a job or with a company and here's problem A, here's solution B, solving, Is that something that the average, and I'm not trying to get you to pass judgment on other data scientists, but is that something that's built into your educational model or into your job, is thinking about the ethics when you're solving a data problem?
Yeah, I mean, that's a great question. I would say probably 5 years ago, I would have had a very cynical outlook on that. And I would feel very like, nobody cares. I feel like there's been a shift. I feel like some of the shift, though, has been all of this really great public discussion that I'm
Right.
sure everybody here has heard. And, really good journalism work, pointing out problems, folks holding large tech companies accountable for unfair treatment and things like this. I think I'm by all means encouraging more of that. And I think that that's having an effect on the data science community, where instead of just being like, well, I'm just an engineer or I'm just a data scientist, like, how am I supposed to solve all these bigger problems? Which is fair, right? Because it's not fair to the individual data scientist.
It's not. And it's interesting, as you said, the more light that is shined on this, the more that people are aware that it is a problem. But I wouldn't think it would be common that companies or solution providers would want to provide data that is flawed or might have a flawed outcome. I think they're striving for the best, and that best shouldn't involve bias, but it's hard to avoid it when the underlying data comes from other issues. I mean, some of the ones we talked about on the show before, I think it was either Travis or Pedro we were talking to about, it's not that the data is flawed. Police really do arrest more of one population than they do another. That's not the flawed data. The flaw is within the police arresting them. But once you run it through the machine learning, then yes, it's more likely the police will arrest people of a higher population because they get more jail time because the data that went into it. So it's not flawed data necessarily. So how do you address something like that, if you even understood where I was going with that? Because that was kind of roundabout.
Yeah, no. I mean, so we have some problems where it's just my data is only one view of the world and there's other views of the world. And if we can work together, we have a more complete view, right? So we have some things like that. And that, for example, could be like skin tones and image recognition, which has a big problem, right? But there's other
and a couple of big scandals.
Yeah. And these are real issues, and people not asking this question in a holistic or again in any type of multidisciplinary or more diversity, anti-oppression aware, right? And so that's some of it, is just like that the field itself needs to be more diverse, right? And then that the questions and the way we approach the problem has to be more thoughtful and more inspired by, what we want this to be able to do, and asking the right questions to make sure that we can get there. But also you bring up, a structural problem, right? Like when we think of predictive policing, particularly, let's take like a metropolitan area in the US. I'm originally from Los Angeles. Let's take LAPD. Not always the best reputation, right? LAPD doesn't have a good reputation. It doesn't have
a good
history.
Example.
And so it's like, okay, I want to build a model. I work at the LAPD, or I work with somebody who's working with them. How do I even approach this problem when I know that my data is going to have structural problems in it itself? It's going to disproportionately affect folks of color. It's going to have oppression, systemic oppression in it. And so it's like, what could I even do if I wanted to do that? There's a lot of really good thoughts around this. So there are some technical things we can do. Some of this involves sampling things differently. So I'm going to take different numbers of the different examples that I see.
Okay.
Some of this is to actually alter the data, right? Or to go against some of the problems.
Okay.
But as you can imagine, these are like little Band-Aids on the problem. They don't necessarily like fix it in a bigger way. And so I think
because it's not.
Yeah. And so I think some of the really good work that's coming out from like Data and Society and some other groups like this is about asking the bigger questions of, should we be building this model if we have to change the data? And I think that those are some good questions, better questions to ask, is like, okay, or why are we trying to predict it if we know that the data is wrong in and of itself? Like, what are we adding to the conversation here?
In other words, wrong question.
And I think that is a great answer to wrap up the podcast, to be honest. Katharine, thank you so much for joining us. I've learned a lot today, and I hope that our listeners have too. So thank you for enlightening us on data science and all that you are doing. To our listeners, I say thank you again for listening to this episode of Serious Privacy. If you like our series, please rate and review us in your favorite podcast app, and do tell your friends and colleagues about us. Should you have any questions or suggestions, if you want to be on the program or have ideas on who to invite, especially for our next season starting in January 2021,
Next season.
please reach out to us via seriousprivacy@trustarc.com or via Twitter at podcastprivacy. You will find Kay on Twitter as Heart of Privacy and myself as Europol B. Thanks for listening this week, and until our next episode, goodbye.
Bye, y'all.
That was Serious Privacy.
If you're a data protection or privacy professional, you already know the pressure. Non-stop regulatory change, AI oversight, internal demands, and the expectation to somehow stay ahead of it all. And the old patchwork of tools just isn't cutting it anymore.
No. That's why TrustArc created a modern privacy management platform powered by Arc Intelligence. The TrustArc platform brings your workflows, evidence, research, tasks, and applications all together in one unified and intelligent workspace, so you don't waste time digging, clicking, or context switching.
With Ask Arc, your privacy assistant, you can ask plain language questions about laws, jurisdictions, or even your own program data, and get credible, cited answers based on NIMBY research and more than 1,000 global laws. It's explainable, transparent, and purpose-built for data protection and privacy.
So if you need to add a vendor, create a cookie banner, or start an assessment, quick actions take formally complex tasks, turn them into bite-sized guided workflows to save you time.
It's a platform that thinks like you, works like you, and helps you move faster with confidence, whether you're a seasoned DPO or you're just getting started.
See how modern privacy gets done. Explore Arc at trustarc.com/serious-privacy. That's trustarc.com/serious-privacy.